Well, hello and welcome to C++ 102 from 3dbuzz.com. I'm here and Nelson's here and Jason's here and it's all going wonderfully.
Hello.
Hello. Good job, Gavin. Good job.
Thank you.
Awesome.
I thought it was I good?
No, I thought it was smooth. You know, for Friday night, it's smooth, man.
Smooth.
Yeah. So, Nelson, what do we got lined up on the docket tonight?
Well, today what we're going to be doing is we're going to be looking at a feature of C++. We're going to be looking at default arguments, spending a little bit of time with that. Then we're going to just start writing code. And we only have a few it's a smaller class, the Unity class, so we should be able to get through quite a bit of code. And I really expect people to be following along and writing code with us. So go ahead and hit participate if you're in the class.
There you guys go. Awesome.
And we're basically going to be putting together some code. I have a bit of code lined up for the day, and let's see how far we can get through it. But by the end of class, we should have something interesting to play with. So, yeah.
Now, there was a little bit of discussion about homework that was taking place over in the BuzzNet about 5 minutes ago or so.
Yeah, basically people have come up with a variety of solutions, and I did notice a bit of a geek contest going on in the thread for the homework of who had the fewest lines of code, which is nice. It's nice to see people are thinking along those lines. But Nelson, how would you do it?
You want me to go ahead and write it out, or?
I think it's only fair.
I do too.
It's only going to take a
It's
couple
not very fair.
of minutes. It is. I want to see you get lots of off by one errors when you're doing it. So do you want to go ahead and do it with a width in a row to win, and then show how you have to adapt that to get it to be a...
I think I'm just going to do the width in a row to win for today.
That's fair enough.
All right, so the first thing, so inside of my rule engine, what I'm going to first do is go ahead and identify the case of a draw. Identifying a draw should be fairly straightforward. What we need to do is simply write a loop saying something like bool found any non-empty, and then we can go ahead and say for auto I equals 0, I smaller than board, get total squares I plus, if board get square at I does not, or if board square equals empty, and we'll start this off as true, of course. Now, for some reason, I've totally forgot the enum. Board square.
Wow.
If it is empty, then we say found any, and this isn't supposed to be non-empty, this is supposed to be empty, equals true, and then break. And then now we can say if found any empty, return, or if... am I totally doing this
Bug on
backwards?
line 131, if that's the way around you're doing it.
No. So if not found any empty, then we return winning player stalemate. So that's the first way to be able to identify if there is a stalemate. So if I run this code, you'll see if I go ahead and fill up all of the squares, the program terminates. Okay, so the next thing that I would go ahead and do is I would write the way to do things across. So we would go through all of the columns and check to see if all the ones across are the same the same player or the same board square, and then do the up and downs, and then do the diagonals. So what I'm going to go ahead and do is write a private method that's going to convert a x and y position into an index. So I'm going to go ahead and say get index for x, y, and it's going to take in an x and a y. And it's also going to take in a width. Then it's going to return width, width times x plus y. what that'll do is that'll give me a linear index for an x and y position. So now I can go ahead and say, for the horizontal, I can loop through all of the rows. So I can say for auto y equals 0, y smaller than board get width, y plus plus. Remember, the width is the same as the height. And now I can go ahead and say board square e all of type. And the first thing I'm going to do is I'm going to go ahead and say, just cheat really quickly and say if auto first index equals get index for xy, y 0. That'll give me the top left, essentially. And now I can go ahead and, or the first item of this particular row, and I can say all of type equals board get square at first index. Then I can say if all of type equals board square empty, then continue, because the first item on this row is obviously going to be empty, and if it's empty, nobody has won for this particular iteration. But if we can go from 1 to the width of the board and still match all of type, then we know a player's won. So now I can say for auto x equals 1, x smaller than board.getWidth, x plus plus. Then I can say if all of type does not equal board get square get index for xy, xy board get width. So if we did not meet this particular match, then what I'm going to go ahead and do is, actually I'm going to go ahead and say winning player e winning player. And if we did not match this, then I'm going to set winning player to winning player none, and I'm going to break out. And then, of course, I have to say winning. Actually, I'm going to move this variable up here to down here and say winning player equals all of type equals board square x winning player x or winning player O. And now at the end of this, if I parenthesize my parameters correctly, if our winning player is not none, then we can return winning player. So this should match all of our horizontal possibilities. So if I go ahead and run this game, and I do 1, and then 5, and then 2, and then 9, and then 3, you notice how it doesn't work. So what I'm going to go ahead and do is set a breakpoint right here and identify whatever off by 1 error I probably just introduced into my code.
You totally fooled me with your intonation there. I was like, this must be going to work. Oh, it didn't work.
Okay, so all of type is x, and if we get the index for x and y, where's my immediate window?
X plus, go up to your where you're doing the multiplication.
Oh, you know what? I think I'm going backwards. I think I'm going down the wrong direction. And I can go ahead and verify that by running this and trying to do it horizontally.
Width times y, i.e. width times the number of rows that you've already done, plus x. So you need to swap x and y in that calculation.
Right. So that was just a minor mistake right there. So now we see that if I go ahead and do 3, we now win. Or x wins in that case. And I can also verify that O should win as well. If I do, let's say O on 7, x on 1, O on 8, x on 2, O on 9. And you'll notice we obviously do have some sort of off by 1 error there as well. So I'm going to go ahead and break on this, do another calculation, so maybe 5, and then wait until y is equal to 2. and then identify what's going on in this case. So it doesn't find the, oh, no, this was correct. It's just I was passing it in backwards. I was passing in y comma 0 instead of 0 comma y for the first position. Oh no, it was both errors.
No, the calculation, yeah.
So now if I go and put an x on 4, y, o on 7, x on that, o on 8, x on 2, o on 9, you see that the program correctly terminates. So that's how you would calculate the horizontal. That's going to be the most basic algorithm to do that. I'm going to go ahead and simply copy and paste this and do it again for the verticals. I'm not going to worry about breaking this out into a more abstract way of representing this logic, because it certainly could. The code's going to look very similar. So now, instead of for auto y equals 0, we're now doing for auto x equals 0. And then instead of identifying the first thing right here, we're going to go ahead and say x and then 0, which will give us the topmost cell for every item. And then we can leave everything else pretty much the same, except for instead of looping through the x positions, now we're looping through the y positions. And everything else remains the same. So now if I go ahead and run this and say, let's put x on 2, o on 7, x on 5, o on 9, and x on 8, we now have our vertical sections working.
Now, we did have a question that came in about what's the benefit of using auto rather than int in your for.
There's no difference. I'm just very used to implicit typing.
Yeah.
Okay, so finally we have to identify the diagonals. So there's going to be 2 diagonals we need to check, and the amount of things that we have to check for the diagonals is going to be simply the width. So what we can do is just write them out manually. Again, I'm not worried too much about factoring this code out, although it certainly could, many aspects of this could be factored out into methods to make it significantly smaller. But what I'm going to go ahead and do is say something like, I'm going to do the same sort of thing that I did before. Do what?
I mean, my approach would be to do because you're basically, all you're doing is checking, well, for the easy diagonal, you've got if x equals y.
If what?
To get the squares. X equaling y gives you all the diagonal squares going from top left to bottom right. And max x minus x, comma, equaling y gives you the opposite diagonal.
Well, in this case, I'm just doing it kind of brute force.
Okay.
This is more or less just brute force because, again, I don't want to spend too much time working on this and factoring it out. So I'm going to just do basically the same thing. All of type equals board get square at get index for x, y, 0, 0. If all of type does not equal board square empty winning player e winning player equals all of type, and this all of type thing is really getting old. And then now I can go ahead and loop for auto x equals 1. X is smaller than board.width get width x plus plus, and I can say for auto y equals 1. Y is smaller than board.get width y plus plus, and then I can say if x equals or does not equal y, continue. Otherwise say, okay, so now let's go ahead and fix the syntax error right here. Let's go ahead and check to see if our parentheses are matched up, because IntelliSense is freaking out. Oh, I forgot the board width. Okay, so now I can go ahead and say the same sort of thing. I can say if all of type does not equal board get square for get index for x, y, x comma y, and x comma y board get width. Then I can go ahead and say winning player equals winning player none, break, just so our outer for loop doesn't spin forever. I'm going to say if winning player equals winning player none, break for our outer loop. And at the end of this, if the winning player is anything, I can say if winning player does not equal winning player none, return winning player. All right, so then I'm going to go ahead. You what?
So are you going to check that one before you do the opposite?
So if we do that, and then we put O on 2, X on 5, O on 7, and then X on 9, that works properly.
Cool.
So finally, again, I'm just going to copy and paste because I don't want to spend a lot of time factoring this code out. And I'm just going to go with the easiest way to do this. Okay, so in this case, I'm going to start with the top right corner, which is going to be x of board get width minus 1. And that's going to be the first one. Then I'm simply going to invert this for loop. So instead of saying x equals 1, it's going to be x get width minus 2. And then it's going to be x is greater than 0. Greater or equal to 0. And then that should pretty much cover this particular case. So now if I put x on 3, y on 9, x on 5, and then 7, we do not get this working. So to go ahead and debug this issue, set a breakpoint, go ahead and get this code running again, we'll notice the olive type is x, which is correct. The first x index is 1, which is correct. It should be x of 1 and actually I didn't do x minus minus, did I?
No.
So why wasn't this an infinite loop? Oh, because I don't know. So x on 3, y on 9, x on 5, and we have an off by 1 error.
That would be the minus 2, I think.
Could be. So x on 3, O on 9, x on 5, O on 8, x on 7. And that doesn't work.
Huh, perhaps it wasn't. In that case, why are you starting y at 1?
Because I've already checked for the y of being 0.
Oh, okay. In that case, get board with minus, it should be x equals, get board with minus,
Okay, so what I'm going to go ahead and do is set up a situation again and then check the logic with the debugger. So put x on 7, y on 1, x on 3, y on 9, x on 5, and that worked actually. X on 3, y on... why am I saying y? Oh.
you'll sound like a Cylon to me.
Okay, so we definitely have an off by 1 error here. So when I put x on 3 and then continue, and then...
Is anyone else having audio problems?
Hello?
Ah, hello? Ah,
Yeah,
must
it's
be my
mine,
end. That must be my end then. Carry on.
Then put x on 5. So now x is 1, y is 2. Now x is 1, x continues to be 1, y is 3. Oh, right, because I'm not derp. So now x is 0, which is what I want. And then, stupid. It's going to be the inversion of this for determining if we're at a diagonal.
It's going to be the get. It's going to be the get max x. X. It's going to be the maximum x minus x is not equal to y.
Maximum x minus x?
Yep. You need to make the same check but on different squares as opposed to making the opposite check. In the same way you did get board width minus the x in your... Yeah, that's that idea. And then you've got an extra -1 probably somewhere in that calculation.
I'll try it first without.
Yeah, that's the way I always do.
Okay, so now let's try a -1. Yay. Okay, so that's how you implement code. Or at least a rough code, basically.
And if you, yeah, and I mean, there's a lot, like Nelson said, that for a start, there's a lot of things which you can factor out into their own bits and pieces. Also, in terms of the checking that he was doing, now that you've got the diagonals in, strictly speaking, you'd want to go through and check that you haven't broken any of the other checks. You're going to want to check every possible...
Right, at this point, you know, that unit testing would be very helpful to determine, but I think everything's straightforward. It's very, very verbose. This is an incredibly verbose implementation. I think it clocks in at, so what is that going to be? That's going to be 248 minus 136 lines of code. No, can't bother to do math right now. 238 minus 136, that's 102 lines of code. So again, very verbose, but again, this is exactly how you would, this is how I approach the problem. You break it down into, okay, so what are the steps I need to do? I need to check the horizontals, I need to check the verticals, I need to check the diagonals. And then you write the code out, see it working, and then factor it out into more concise code. Obviously, like I said, this is very verbose. If we look at the difference between the check for horizontal and the check for vertical, the only difference is one we're passing in x and y, one we're passing in y as the first parameter, then incrementing y right here, and the second one we're doing x as that parameter. Breaking that out with like a lambda, for example, could make this, could factor out both cases very simply.
And of course, yeah, you could further combine the checks and interleave them, if you see what I mean, because you're doing very similar logic all the way through. Sire actually nailed it down in BuzzNet. He said yes, but he did it in 5 minutes, and now he can refactor it.
Right.
That's the big key. If you're coming from a blank sheet, code that is long-winded, but you can see what every line does instantly and very easily step through it and follow the logic that's going on, is far more use for a first pass, if there are any problems, than some incredibly briefly stated and concise, loaded with lambdas and link-esque.
Oh, someone did point out a valid
thing.
Bug. They said bring the stalemate down to the bottom. That's a good point, because if somebody wins on the last turn, it would return a stalemate.
True. I don't remember the specifics of it. I imagine they're on Wikipedia. But I do remember at school we studied this because mathematically it's an entirely solvable and predictable problem. You can guarantee a stalemate if you've got two players who both know how to play it properly. There's always, so it's, building AI for this would be quite an interesting, straightforward project, relatively. Anyway, I'm probably kind of rambling there.
Ooh, I made stuff backgrounds. Wow. Why is my words failing? There we go. And of course my 4 is not going to look very good because of that. But if I did like 1, 5, 3, 9, 4, then what's that going to be? That's 9, 10, 11, 12, 13. I win.
So, basically, I know it's early. That would probably be a good time to take a short break and let anyone who has further questions about what you've done homework-wise ask them. And then you can come back, deal with those, and move on to the heart of what we're going to get into today.
All right. Yeah, I really did. This was the implementation I was really expecting to see from people, just because this spells out the logic just entirely in code. And if people shortened it, that's great as well. But
there's no reason that people should be, just think that because somebody else has got their code down to, 10 fewer lines of code than them, then they should give up programming and turn to flower arranging. If it does the job and does it within the parameters set out, then all is good. Move on to the next job. In the real world, you can't, unless you're specifically setting out to wring every possible ounce of performance out of something. Life's too short. You need to get things done and get it done and move on to the next thing.
Right. Alrighty, so go ahead and bring in questions. I'm going to go ahead and pause for a few minutes. Ready, and we're back. So, wouldn't it have been easier to do a double array instead of a single array for this? Yes and no. It's easier to...
You mean a
two-dimensional
array?
Yeah, he's referring to a multi-dimensional array. Regardless of what mechanism we use to instantiate the squares, because of the way the class board is written, we'll have to be doing dynamic instantiation anyway. And when I went to actually go and write the board, it just made more sense to me to instantiate it as a linear array instead of a one-dimensional array, as opposed to a two-dimensional array, which would require more instantiations, a little bit more complex code to start up on. Not to mention that the board doesn't really have a height. I mean, I guess it does, but it really just has a width, because one of the constraints of this is that it's always going to be square. So that's the answer to that. And I decided to just go with indices instead, and converting between the two is fairly trivial. Coming from a C# background, do you know what the equivalent to an event would be in C++? C++ does not have events, nor does it have delegates. What it does have are function pointers, which is the closest thing to an event in C#, and as you know, in C#, events and delegates are tightly related. However, when implementing an event-type system in C++, what you would typically do is implement what are called functors. And functors require template metaprogramming. But what they allow you to do is they allow you to pass in either a class that represents... So it's just like let's say you make a class called... or an interface called iButtonClickEvent. And then you implement that interface and it has one member on it. And then you add objects of that interface to your button, and then every time your button is clicked, it loops through all those interfaces and invokes that method on it. But what you could also do is use functors, and functors are a very more advanced feature, or not really a feature of C++. Functors are more a consequence of operator overloading and template metaprogramming. But what functors are is it allows you to do one of two things. Either pass in a function, well, three things. You can pass in a function, not a member function, but a normal function. Or you could pass in a object, so you would have to instantiate a class and overload the parenthesis operator. And wow, that was terrifying.
What was?
Did everybody hear that?
No.
Surprised that didn't pick up on the microphone, because there's a huge flash and then all of a sudden... Anyway, moving on.
It was clearly Thor is taking the class and wants you to get back to the 102 level as opposed to the 104 level that you appear to be going into now. And he did actually state that he didn't intend for that to be answered in the video, as it goes way beyond the class.
Oh. And then finally,
And we'll start a
hold
question
on,
about
last thing, just to
the
complete
code
that,
that you have got there.
for anybody who's listening, just to complete that, the final thing you can use in a functor is the C++ 11 lambda syntax. Okay. So, hopefully my house won't burn down. We do not get thunderstorms very often in this city. In last week's class, I didn't like, in the code, how current player was set by winning player. That was very confusing until I figured out what was going on, because I kept trying to figure out what winning had to do with what player was being passed into current player. That and board.setSquareLine were confusing. Is that really how you would name it, or is that how you happen to name it for the first version of the game? I fully intended to name this set square. Fully. And as far as winning player, that's just the name of the thing. I don't know what more else to say. Okay. So, sorry. If you can be maybe more specific about that. I mean, if you look at the syntax, the winning player is the winning player. So we keep track of the winning player and the current player. And we use the winning player to ask the rule engine, as you see here on line 79, if a player has won. And then we use the current player to keep track of the current player. So that allows the syntax to be fairly straightforward. Or you're talking about the winning player struct itself. Now, winning player is a struct, but I'm using it as an encapsulation of an enum. But line 9R? I don't think I have a line 9R. Line 97... Yeah, all that's doing is it's converting, but this line converts between a winning player and a board square, and this line converts between, or doesn't convert between anything, but swaps the winning player. So if the winning player is X, what's returned is O. If the winning player is O, what's returned is X. So it's a very simple way to just swap an enum.
Cool. So that covers the homework and a few other questions. What's on the page for today? We're going to be studying are we?
Indeed.
Cool.
I mean, I hope people understand why I do that. I typically am used to having a garbage folder on my computer where I put garbage projects, and for some reason, Visual Studio does not pre-name projects to something unique for C++. I believe it does in...
Doesn't C#.
It does in C#, I believe it, and in F#, and in VB. I believe it also does in 2012, and someone just confirmed that. So once we get up to working with 2012, we won't have to deal with these awesome, highly semantic project names. And one of these days, I'm going to come up with a conflicting name, I swear. Okay, so the only really new bit of syntax we're going to be talking about today are default arguments, and that's it, really. And then we're going to get on to coding. So what are default arguments? Well, we've talked about overloading before. So for example, I can write a getInt function that takes in a string prompt, and obviously I'll have to import the string header for that. I can just say string prompt. And then I can go ahead and say, or actually I can't make this a reference. I could make this a const. We're not talking about 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 const. We will be talking about const, don't worry.
I was worried. I am worried.
About const? Oh, it's a fun little rabbit hole in the C++ language. Okay, so I can go ahead and say getInt, and I can say age. And I can say int age equals, or auto age equals. And then cout you are age years old. And then sin.get. Okay, so now when I run this program, we'll get the expected result. Nothing super fancy. So I imagine everybody is already familiar with this code. I shouldn't have to explain this. But what we could do, and what a lot of people like to do, in a lot of different someone was just about to be booted from BuzzNet. In a lot of different situations, people might use this mechanism to deal with default arguments. So now you'll notice that we have two getInt functions, one that takes in a string, the other one that takes in nothing. We have effectively overloaded the function. So now I can just say, instead of getInt age, I can just say getInt and hit F5, and you'll notice it delegates appropriately to the correct function, giving a valid default member. But there's another way to do this. In C++, there are default arguments, or default parameters. Really quickly, let's talk about what the difference is between a parameter and an argument, because this is a thing that is confusing to a lot of people, and I try my best to use the right term in every situation, but sometimes I fail because they're so closely related. A parameter is what a function takes in. A function takes in a list of parameters. So prompt is a parameter. However, if I were to pass in the string literal age into getInt, this is an argument. It's an argument because it is an actual value that is being applied to a parameter. So I just wanted to get...
It's much the same relationship as a key and a value in a dictionary.
Right. You have a specific, key, a specific placeholder, and then you fill it up with a specific value.
Hmm.
So,
but anyway, that's guaranteed to. I certainly will probably end up calling parameters arguments and arguments parameters, and probably so on else, and everyone does at some point.
I try my best to whenever I'm talking about programming, I really try my best to be as close to the actual language as possible and the specification as possible, but you'll mess this up. However, if anybody was curious about that weird little thing, what's the difference between a parameter and an argument, well, there you go. Now, default parameters in C++ are possible, and they're possible via this syntax. So now what we have is getInt, and it says equals number. Now I can invoke getInt without passing in an argument. So you'll notice I'm not passing in any arguments into the getInt function, but I am invoking the function that's defined on line 5, which clearly does describe the existence or define the existence of a parameter.
It's basically exactly the same as if you just inside of it said if the parameter was non-existent, assign number to it.
Right. Somebody asks, is it automatically overloaded? And the answer is no. It's not that it's automatically overloaded. It's that the C# compiler will literally say, the C++ compiler will literally say, hey, look, here's a function. You're not passing in a parameter or argument to the prompt parameter, but it does have a default expression. So what I'm going to do as the C++ compiler is take whatever on the right-hand side of that equals, copy it, and paste it into the call site. So it's not like you're defining the existence of a new function per se. You're not creating an overload. You're just making a default parameter. That's much the same way that the C# default parameters work as well. But there's an important distinction between C# parameters and or C# default parameters and C++ default parameters. For example, notice how if you're familiar with C++ or C# if you're familiar with C# default parameters, you'll be aware that you can only assign constant values to C# default parameters. Now remember, in C#, although strings are indeed a reference type, the string literal syntax makes it a constant. In C++, you can assign almost any expression to a default parameter. So for example, I can go ahead and say, create a class, class A, and I can go ahead and say public class A, int I, cout, creating a class A with an int I of I. And so now I can have get int. I can pass in a, let's say I want to say class A CLSA equals class A 10. So what's the output of this program? Ignoring the user input, obviously. I think everybody's asleep.
No, I'm just, well, yeah, they might be. I'm looking at it going, actually, that's just horrible. Because, well, I mean, class A.
This is a bit of syntax I don't think we've really covered yet. So we're going to be I think we should be talking about that syntax a little bit. So now when I go ahead and hit F5, you'll notice we say creating a class with an int I of 10. And if I break it out into a new line, it might be a little bit more apparent. So we'll notice that the default parameter that we specified on line 14 was an actual expression. This class A expression invokes the class A constructor and returns an instance of a class A. And because that expression invokes the constructor of class A, we can prove with this code that I have written here that class A is indeed being invoked, or the constructor for class A is being invoked. However, if I went ahead and did this, or sorry, if I did this, notice how we invoked the constructor of class A before getting into getInt, because we instantiated a class A on line 25, and then we passed it in as a parameter line 28. And by passing it in as a parameter to line 28, it makes it so that the default parameter doesn't proc because, well, it is not needed. So who's having an issue with this sort of concept?
It's, I mean, it's really, it's, I don't know how else to explain it, really.
I mean, well, let's just whiteboard this.
Well, all it is you're giving a default, and if you then don't pass a parameter in, it uses it.
It is a really simple concept, but maybe for people who are having a difficult time visualizing this, let me go ahead and just draw something with arrows. And for the people who are getting this, feel free to make fun of my whiteboarding skills.
Your whiteboarding skills suck.
Well, my tablet doesn't turn. Oh, maybe I should plug it in.
See? The very basics. You know, actually being able to interact with it.
Indeed. Well, I'm using the wireless dongle, so it's a little bit more complicated. Okay, so...
Well, I tell you what, Tic-Tac-Toe is quite a good example. Your grid size.
True.
Because, you know, if you say Tic-Tac-Toe to people, they think 3x3 grid.
Right.
So that would be an obvious default.
This bit is...
I'm just trying to idea.
Well, I'm just going to complete the code here just for this example. That is a good candidate for defaultness, though. Okay, so when we're inside of main, and we invoke getInput and pass in hey, as a slanted, and pass in hey, what we're doing is we're applying the hey argument to the prompt parameter. This has nothing to do with defaults right now. We're applying the hey argument to the prompt parameter. For people who are not getting default parameters, currently, right now, just ignore this bit. And please tell me that this makes sense.
That makes sense. And your whiteboarding sucks.
Okay, so what if we say get input? Well, I'm really self-conscious today.
You should be. For your whiteboarding sucks.
Well, yeah, you put me on the spot earlier with that Tic-Tac-Toe implementation. I think that's ruined my self-confidence. Okay, so now what we're doing is we're invoking get input without a parameter, or without an argument, sorry. What happens here is the C++ compiler literally translates this code right here into oh, well, that should be capital N. The C++ compiler does this because it knows that there is no parameter or no argument being passed in, but it knows that there is a defaultness already supplied for this parameter. So what it's going to do is it's going to take everything on the right of this equal sign, which is right here, and it's literally going to bring it down and copy it into the parentheses behind the scenes for us. Okay, that's what default parameters are.
Do you want to, just because I thought of it and I'm great, have you still got the Tic-Tac-Toe open?
Maybe.
The code. You could add one in?
Yeah, so if I jump back into the Tic-Tac-Toe and look at the level or the board class, I can go ahead and supply a default of 3 by doing that. Whoa. Where are you?
By highlighting everything.
Okay, so what I can do is assign the parameter width to have a default of 3. So now what I can do is if I jump all the way down to main, I no longer need to provide a parameter to the constructor. I can simply say board board, and I get a board with a width of 3. If I wanted to override that parameter, I could go ahead and say give me a board with 50 squares, and that would be a fun game. I don't know if anybody heard it, but my computer was to the right of me beeping because I think I hit one of the beep control characters in ASCII a few times.
So, yeah, you'd probably want to put some sort of maximum limit.
Yeah, but still, though, the point is you no longer need to pass in a parameter or an argument to this parameter.
And one thing that, just using this as a further example, one thing that this opens up to you now is the ability to, for instance, at the beginning of main, throw it on your start screen that looks amazing and has all sorts of ASCII pictures. You can put up, please choose board size, but which you could have done before, but now you can say, please choose the board size or hit enter for a standard game or whatever. And that means that if people don't pass in, well, not only if they choose not to pass in a value, but you could set it up so that if they pass in a value that's gibberish, if they hit a letter or it's just a wrong value, you've still got an elegant way to go with a default. Well, that's what default means, standard. It's the
It's a standard.
default. It's the. I literally couldn't find a synonym then. It's the word. Yeah.
Okay, so does this code now make sense to people?
Daniel's asked a brilliant question.
All right. If you have multiple parameters, can you have some with default parameters and some without? If C++ supported named arguments, then yes. But what you have right now, or, well, kind of, I guess is the answer to your question. Notice how I can invoke getInt, and I can pass in an implementation or a object of type class A into the first parameter. And if I run this code, you'll notice that the second parameter actually did get filled in for us. However, there's no way to jump around. Like, for example, if string prompt doesn't have a default, notice how getInt is now an error. Default parameters may only be at the end of a method or end of a function, because how can we not specify the first parameter without specifying the second parameter? And if the second parameter doesn't have a default, then we must specify it. And then the world ends.
So you can't do. So things that you can't do include just comma separated, space separated commas almost for missing parameters for one.
You what?
When you're calling the method.
Oh, right, yeah, you can't.
Like comma, comma, comma.
Yeah, you can't do this. Although IntelliSense makes it seem like you can. Obviously, when I go to compile it, I'll get an error. Now, some languages, actually all languages that support default parameters, to my knowledge, do not even support this. That's a silly feature to support.
Yeah, similarly in C#, they have to be at the end of the list.
Yeah, what's happening on line 14 is I'm defining two parameters, each with defaults. So, for example, here's parameter number 1, and here's parameter number 2.
This is, I think you're probably just overthinking this. This is exactly the same as normal. I mean, if you just, Nelson, remove the default assignments a second.
Well, maybe not.
No, yeah. Because the point of it, these are just normal
Functions.
normal functions with a parameter list. It just happens that you can you add equals and then the value you want to be the default.
Yeah, so then we do
to what's there.
That, and then this is, the first aspect of the default parameter. I don't know if I'm visualizing this in a way that makes it more or less confusing. And
more probably.
Well, I've already gone this far, so I'm going to finish it.
No, absolutely. It might.
So this bit right here is the aspect of default parameters. Everything else is just normal parameterness. Yeah, well, class A of 10, or class A with 10 being passed in, is just invoking the class A constructor and returning a class A object. In C++, that's how you invoke constructors without doing dynamic memory allocation. No, you don't need a new keyword. Unlike C#, where whether or not something goes on the stack or the heap in C# is determined by a variety of language-specific criteria, in which C#, when you new something up, you use the new operator, you may or may not get dynamic memory allocation. In C++, new means dynamic memory allocation. You will never use the new keyword and not have the resulting operation be a dynamic memory allocation. So that means I don't like that as much personally. Well, I go both ways. On the one hand, it's very explicit in C++. When are you dynamically instantiating memory? Well, if you're using the new keyword, you are. If you're not, you're not. But that also leads into things that may look funky to C# developers, where it was a C# developer or a Java developer may instantiate a value type using the new keyword, even though that's not being resulting in dynamic memory allocation. In C++, if you want to instantiate an object without resulting in a dynamic memory allocation, you use syntax such as what's highlighted on line 15, or syntax like what's highlighted here on line 27. Or failed to be highlighted. So defaults have to be at the end of all your parameter, at the end, or all your parameters will have defaults. No, it'll just be an error. So if I go ahead and bring this function prototype or function signature to sanity. So if I went ahead and added a int woe to the end, I'll get an error. But if I had the int woe at the beginning before the default parameters, I won't get an error. So you can have as many default parameters as you want, but once you start down the path of default parameters, you can't go back.
Just make sure you don't get your hand stuck in the cardboard tube. Did you see there's one question, another one of Chris's that I flagged up, green?
Class stuff.
No, the one that I flagged.
If you have two constructors, one that takes a default arg and one that is blank, what happens when you call the constructor with no args? Well, that's a good question. So, like for example, let's say I have a getInt, and then I also have a int getInt.
That is a good question. He's good questions.
What's the output to this program?
I'm with dual op amp just on the basis there's a big red squiggly sat in the middle of it.
Right, sadly. Now, it lets me define this because C++ is like erp to derp. I know you can never invoke this function, but I'm still going to let you define it without me airing you out on even the definition of the function. But when you try to use it, I'm going to yell at you. And that's exactly what's happening right here. We were perfectly allowed to do this per the rules of C++, but when we went to use it, it was like, well, I don't know if you want to invoke the first getInt or the second getInt.
I love how in your mind C++ has got the same accent as the Swedish chef from the Muppets. So is there a way around this?
No,
or not?
The way around it is that you disambiguate your functions.
Yeah.
And that's it. I mean, there's no...
The thing is, because we've gone back and forth on this, in fact, you've gone back and forth on this yourself, I know, in C#. We were talking about it just the other day, though. Which is better? This is one of those things that's kind of like the whole Max Meyer Windows MacOS.
Well, except for
thing.
in the case of Windows and macOS, there's an obvious clear winner.
Yeah. The point being, this is an alternative to, or in many ways, to, you have the option of either doing this or overloading.
Right.
Or sort of in combinations, but I would suggest that it should be fairly obvious that you want to either be doing one or the other, because you're going to tie yourself in knots otherwise. Sorry, Karen.
In C#, I typically avoid default parameters, and one of the main reasons why I do that is specifically because whenever I turn on fxcop, or whatever Microsoft renamed it to, a tool provided by Microsoft that checks your code, if you have a default parameter as one of your...
Hello?
Oh, never mind.
As one of your
Nelson?
Oh, sorry, there's just a huge thunder again. Surprised you don't hear it. Anyway.
I love how you're in this bizarre world where you don't understand the base, like rain falls out of the sky.
Well, I don't think
like
you understand.
Panic every evening when the sun goes behind the horizon that it's never going to come back again.
You still don't quite understand that we never get lightning or thunder. But anyway, I don't do it in C# because in C# the tools provided by Microsoft to validate the integrity of your code will actually yell at you if you use them on public members. There are many reasons in C# not to use them. One of the biggest reasons is that when you're doing interop between C# and other .NET languages might not understand default parameters. Furthermore, default parameters are an aspect of the C# compiler and not of .NET. In C++, things are a bit different because you're not going to do interop with other languages with C++. There's no common infrastructure that you can compile to other than, of course, assembly. And in C++, there are fewer reasons not to use default parameters. when working in C++, I will choose default parameters over overloads, as long as the expressions of what my default parameters are defaulted to are relatively simple. And that's because I feel that the syntax is a little cleaner, it's a little shorter, and it doesn't have the same issues as in languages like C#, where, like I said, there are many issues with using default parameters in that language. What if you had get int prompt equals 10 in the string one? Oh, well, that's a good question too. If I had like a int woe equals 10, you'll still know that there's still an ambiguous call. Ask yourself, do you know, based off line 21, if you intend to invoke the function on line 14 or the function on line 5? Well, I mean, I'm sure when writing the code, you intended to do one or the other.
What you meant to say was, out of context, if you just read line 21, could you then know for sure whether you want to go to 14 or 5 at that point?
Right. Now, we could certainly just forego the default parameters entirely, but then that makes it less useful, obviously, because then you can't use them. By this I mean you can't use default params if you have overloads. No, you can. Like, for example, if I have a get int that takes in a float f and then a default int, and then a get int that takes in a double d and then a string. Now what I can do is say, okay, well, I want to pass in a double. And you'll notice that when I run this code, the correct method on line 5 gets invoked because we disambiguated the function call by providing the first parameter. However, if I were to convert this into a float, we'll get the function on 14 because, again, we're disambiguating that. You can look at this code and realize which function should be invoked.
Cool. I think that we've pretty much covered default parameters, have we?
Yeah, I think that's all I really wanted to cover. Yeah.
So,
okay.
What's next?
So what's next is we're going to be writing some code. For all of the people earlier who weren't able to, or didn't get up, I'm going to go ahead and pause the video again for a few minutes. So let's go ahead. And we're back. So I'm going to go ahead and I'm just going to reuse the same source file or the same project to go ahead and start implementing some code. So I want everybody to go ahead and hit participate because we have a lot of code to type out. And if people have questions while we're typing out code, then please, well, post them in the questions panel. That's why we're here.
I have a question.
What's your question, Kevin?
What this code, this awesome code, what is it actually intended to do?
Oh, well, it's probably, I know we did talk a little bit about it last week, and it might be a good idea to recap it now that we're, about to write it. What we're going to be putting together is a really basic real-time console-based shooting game thing. And what I wanted, similar, if people are familiar with Evil Monkeys, it's going to be similar to that. But I wanted to make it a little bit more interesting. I know that in C# 102, we spent some time talking about design and stuff like that, and I felt that it would be an interesting exercise to go ahead and build out an engine in C++ that uses some design methodologies. Now, there are a few caveats. This isn't going to be that big or complex, but we will be using polymorphism, inheritance, and all that fun stuff. And not only that, I do also want to point out that the rendering code for what we're putting together will unfortunately not be cross-platform. And I greatly apologize to those of you who are working on different platforms. If there are people who are working on different platforms who are unable to find the analogs to what we're going to be putting together for your platform, let me know in the forums, and I'll do my best to go ahead and reconcile those differences in the API for you. I want to point out that one of the reasons why C++ doesn't... it's funny how everybody says, I want to write cross-platform stuff. I need to learn C++. It's funny, though, because a lot of the things in C++ are very platform-dependent as you work on them. There's not a whole lot of abstraction. we're going to have to tie in directly to the Win32 API. And we're also going to be using a header called CONIO, short for console.io. Now, in Windows, a console window is fundamentally different to the console windows, and I'm finger quoting here, of Unix-based systems. And of course, when I say Unix-based systems, I'm referring to Mac OS and Linux. Mac OS and Linux have terminals. So a terminal is sort of a different concept than a console, although there are ways to do what we're going to be doing here in terminals. So let me go ahead and talk about a few of the APIs that we're going to be using in Windows. I don't know if we'll get to the point in our code where we'll be taking advantage of these APIs. However, I do want to point them out and have them available for people to look at so that maybe people can have something to play with, at least as far as interactivity. The two things that we need to be able to do that are going to be platform dependent are going to be retrieving a single character from the input stream and setting the position of the console cursor. So I'm going to go ahead and do setting the position of the console cursor first, because this is going to require a little bit of annoying code to write. The Win32 API is fairly meh, is the best way to put it. It's not the...
Could you expand upon that at all?
Well, the Win32 API is notoriously strange to work with. One of the reasons the Win32 API is strange to work with because it was really developed for C. You won't see any classes in the Win32 API because it's all about C code. And obviously C does not support classes. So what I'm going to go ahead and do is I'm going to write a function. And we will be using this function later down the line, but it'll be in a more appropriate location. But I want to go ahead and write a function out really quickly. And everybody who's on Windows, I want you guys to write this function out as well. So you'll have it on hand if you decide to go further with the code than we are able to do today in our allotted time frame. So the first thing we're going to have to do is include windows.h. Windows.h is the big, scary entry point into the Win32 API, and it provides pretty much all of the functions that we will be using. Remember, I said the word function, well, on purpose, because that's all we're going to be working with. There are no classes.
So there was a quick terminology question that came in.
What's the difference between the...
which is what...
A console and a terminal. Well, it gets a little. I guess the best way to sort of conceptualize it is well. First of all, let's take a step back. The reason I differentiated between a console and terminal is that if you are looking for Unix help, you use the word terminal, and if you were looking for Windows help, you use the word console window or command line. I guess the biggest difference, sort of to conceptualize it, is to think of a console as a sort of fixed buffer of characters. For example, if I go ahead and fire up a console window, something I hope most of you are familiar with at this point, this has a fixed buffer of characters. You'll notice that if I scroll down, it's just one big buffer, and that's it. A terminal is a little bit more fluid than that. A terminal is more or less just a stream of characters that get printed out. With a terminal, what you have is basically, you'll notice that a console window in Windows is a program that we launch. So, well, a program that gets hidden by your VM because...
cmd.exe, is it not?
Yes. It's an actual program. A terminal is a little bit more complicated, and one of the reasons it's more complicated was a terminal, all the way back when, was really just a terminal. Like, that's all you had. You had a terminal. That's what you connected to your computer with. And what you have nowadays are what are called terminal emulators, which sort of emulate the experience of dumb clients that were used with mainframes, essentially. And so mainframes, all they did was they shot text to a dumb client, and all a dumb client did was it shot text back to the terminal. And that's it. Everything for things like clearing a terminal, printing a terminal screen, moving a terminal character, changing the color of a terminal, all of that stuff was handled by special escape sequences that were sent by the mainframe. And to this day, that's typically how things like Unix terminal emulators work. And when I say Unix terminal emulators, I'm of course talking about the different shells that you have, like Bash, or the Born Again shell is the most familiar, I think, with everybody here. And so it gets into a really complicated sort of thing where they sort of kept that moniker throughout time, whereas with Windows, because Windows became primarily a graphical operating system as of Windows 95, they basically took what used to be your only interface into a computer and stuffed it into a program for you. Oh, I don't want to say that the terminal in Linux is not, terminals in Unix are not powerful. In fact, because of the pervasiveness of terminals in Unix, there are many, many incredibly powerful scripting environments that are based solely within the terminal on Unix systems. Bash, again, Born Again shell, has a really excellent sort of scripting platform associated with it. And you can do some really fun stuff with it. It's not unlike PowerShell. PowerShell is a fun little program that Microsoft put together that's hopefully one day going to replace the old CMD window, because it's a .NET compatible terminal language thing that's really actually quite awesome. I used it today to do some fun stuff. Okay, cool. So we should do a PowerShell workshop. Anyway, so I'm going to go ahead and pull in the windows.h header. So go ahead and pull that in. And then I'm going to write a function. And this function is simply going to abstract away the few different lines of code that we're going to need to deal with setting the cursor position of a console. So I'm going to go ahead and say void set character char ch int x int y. And then I'm going to go ahead and say chord pause equals xy. I'll talk about that syntax in a second. Then a handle output equals get std handle. Then I'm going to pass in the std output handle define. Then I'm going to go ahead and say set console cursor position. And I'm going to pass in the output, the handle for the output stream, as well as the chord that we defined above. And I'm going to simply see out a character. So now if in main I do set character A at 2x2 and then cn.get, you'll notice that A is appropriately set by 2x2. So breaking down this function a little bit, first thing we do is instantiate our chord. And if we look at the definition of a chord, all it is, ooh, I did want to point this out just for a second. I know in C++ 101 we talked about how structures, the syntax for defining a structure is a lot nicer in C++ than it is in C#, or it is in C. That's how you used to define structures in C. Super fun stuff. And that's not supposed to be taken seriously. So you'll notice that what we have here is a struct called chord. This is a coordinate that's commonly used in the Win32 API. If I jump in, now you'll notice that it uses two shorts. What's a short? You'll notice that it's all in caps. If I go to the definition of a short, you'll notice that a short is just a short. That's all it is. So what we have here is a structure that has two fields in it, x and y, and they're both of type short. So that means when I instantiate a chord, I can simply use the struct initialization syntax to fill both of the fields up by passing in the x integer and the y integer, which of course then get implicitly converted to shorts, which in C++ inexplicably require the same amount of memory. Next thing we do is we get a handle. And a handle in C++ in Win32 is a fun little concept that is used everywhere. You'll notice that the type def of handle is only a void pointer. Now we haven't talked about void pointers yet, and we're not really going to. Keep in mind that all a handle is it's a type def for a pointer to anything. But what Win32 uses handles for is it uses handles to access native resources. So we use handles, in this case, to get the standard output stream. Or we could use handles to do other things, such as, files and mutexes and all that fun stuff. Although in the cases that you use handles, sometimes they're not necessarily going to be handles. For example, to reference a window in Win32, you use the HWND type def, which of course just simply stands for handle of window.
Cool.
Next thing we do is we invoke the set console cursor position function, which I don't know needs much.
Fairly self-explanatory, I think, that one.
Exactly. All we do is we have to pass in the output handle to our output stream and to identify our particular console window, and then we pass in the coordinate that we constructed.
Now, is there any, I suppose two questions, is there any way to access for yourself what the handle is for a particular console window or whatever, or is that all just stuff that goes on behind the scenes that you really don't need to?
You don't care about it. The handle is an abstraction. You get the handle from something, and then you pass it into things that expect a handle.
Okay.
You're not going to pull apart the handle itself because the numbers are only meaningful to Win32.
Okay, cool.
Okay, I really want people to have this function handy in a notepad window or something, just in case we don't get to the point in this class where we'll actually implement it on screen. So go ahead and hit 1 more minute if you're still typing this stuff out. Don't worry about the implementation of main, just have this function defined.
I think it's fairly likely we'll get to the point where you type it out on video. Probably about 5 minutes ago, when you typed it out on video.
I mean for the rest of the code that we're going to be playing with.
It's just weird. It's just, I don't know, perhaps I just heard it weird.
Why should one define short?
I was wondering that, actually, seeing as we're paused. It does seem unnecessary to me. Just for house style consistency.
It's just how it works with this, and that's it. There's probably a good reason. The reason probably has to do with some sort of compiler compatibility or something like that. The ability to reuse the same headers between compilers and modify the types that they take in. That being said, I don't see a situation where short would ever be a short. Alternatively, it could have to do with compatibility with C. I'm not 100% sure about all the data types with C. I haven't actually really ever done much C programming, but it could be for compatibility with C and C++. It could be compatibility between compilers. It could be one day one person woke up and said, "I really like uppercase keywords."
I suppose, I hadn't really thought about the fact, but given the things like, well, certainly like short, long, int, float, double end, those sorts of things, they are the things where those are the two options that you're likely to have.
Well, actually,
and those two options cover every possible scenario that you can think of, and it's probably just, like you say, compatibility.
Well, yeah,
it's an easy way to double the compatibility of this piece of code.
Well, in even looking down on this in this same file, notice here it says if not defined to Mac, define wchar-t, which is the wide character or Unicode character for C++, to w character, and then underneath the else statement, there's a comment that says some Macintosh compilers don't define wchar-t in a convenient location or define it as a char. So then it defines a wchar as a short instead. So I'm sure that situations like that are why they chose to do this. And if I scroll through this file, I'm sure I'll run into other commented out things. Like, for example, if Unicode is supported, then define... Don't you love these names? Let's read one of them out. PCNZWCH is equal to PCNZTCH. Yay.
What does that stand for?
I think it stands for pointer to a wide character, but I don't know what the Z means. And then you'll notice that down here there's different defines added depending on if you have Unicode support. Engage.
Nailed it. It looks like your project names. But cool, everyone really ought to have that typed out by now.
Yep.
There's only a few lines of code.
Okay, so did the core definition not have an underscore at the beginning? Well, yeah, it did, kind of, but that's not the relevant bit. You don't use the underscore bit, you use the typedef to chord. That's another convention that you'll see prevalent within the Win32 API. And then you'll notice that a pointer to a chord is typedefed as pchord. Typedefs are a fun little thing that I think that we should talk about maybe next week, because they don't take a long time to explain, but I realize that we haven't talked about them yet.
Cool. So,
Okay.
marvelous. We've now got an A in set.
What I'm going to go ahead and do is I'm going to go ahead and back up. I'm going to create a few header files for the different headers that we're going to be putting together. We're going to be putting together 2 interfaces and 1 class, just for now. And I'm going to get the definitions of these interfaces and classes up and running. I'm also going to define a basic value object called position. So actually, I'm going to start off with defining that value object. I'm going to create a position.
And this is .h file.
I'm going to say class position int xy, xy, public position int get x, int get y, int x, int y. This is simply going to be a very straightforward immutable type. Now I'm going to go ahead and create the corresponding CPP file because it should be fairly straightforward to anybody. The CPP file is simply going to say include position.h, int x, int y, x, y, int position get x, return x, int position get y, return y. So I really, because we're going to be using the concept of an XY position so frequently, I really wanted to combine an X and a Y together into my own class for use for whatever. Okay, so I'm going to go ahead and hit reset. Everybody's ready. And go ahead and hit 1 more minute if you are still working, or ready if you are ready. So let's go ahead and add in 3 more header files. So now that we have our position, we need 3 more header files. We're going to have a tile. What a tile is, actually, hold on, this isn't a tile, this is an iTile. It's an interface. I really wanted to have the concept of polymorphic tiles and polymorphic entities. And when we get to our level class, I'll explain what the difference between the two are. So an iTile really only has a few different things in it. It's going to have a... actually, I shouldn't have started off with this H file, but you'll see why in a second. It's going to have a char get character, representing the character of the tile, equals 0, and virtual. Then it's going to have a virtual bool can enter entity reference. And I know we haven't created the entity yet, which we will in a second. And it's going to have a virtual void enter entity reference. Okay, so what we're going to do is we're now going to also create an entity header, or an entity interface. So the entity interface looks like this. It's going to have a virtual char get character. It's going to have a get position, so I'm going to have to include in the position.h file. So a virtual position get position. And now keep in mind, because position is immutable, I can safely pass around references to it. And then I can go ahead and say virtual void set position. Position equals 0. And although we will not be doing much with this method for now, not this week definitely, maybe not even next week, I'll throw it in there just so people can get an idea of what's going on with this class. I'm also going to put in a virtual void collide entity, just for some foreshadowing.
Ooh.
Then I'm going to go ahead and pull in the entity definition from tile. Okay, so the last class that I'm going to go ahead and want to put together is going to be the iLevel. Or not iLevel, just level.
If you could just go back to your entity, 912.
Oh, thanks.
It was K73. It's part of that one.
Thanks. Okay, so what's the level going to be? Well, a level, I'm not going to worry about his private fields for right now. A level is simply going to be a thing that contains, well, tiles and entities. It's going to have a constructor that takes in a width and a height. It's going to have a int get width method and an int get height method. Then it's going to have a few other methods. For example, we're going to have a void set tile method that's going to require an iTile reference, which means I'm going to have to pull in iTile as a header so that we get that definition. I'm going to say set tile with a position. Then I'm going to write another one called set tiles. Once I get the definition here, it should be fairly straightforward. Set tiles will lay down tiles in the level from a position to a position, defining a rectangle. Then we're also going to have a void set entity. So that means we need an entity include. And then we're going to have a void move entity. And finally, we will have a void initial or render all, which will basically refresh the entire rendering. So basically, this is really the entirety of the game's level that we need to really model out. So I'm going to go ahead and have the level sitting somewhere. Maybe if I go to full screen, I can fit it in somewhere. So these are the 3 H files that I really want people to go ahead and type out.
K also was querying something about line 17.
Line 17, what is it? Oh.
Oh, wow, even after noticing the question, I couldn't see what you'd done there. Yeah.
Okay, so now I'm going to go ahead and pause the video. So I just need to make sure that I also include position and level. It is a little bit frustrating because H files do not compile. Meaning if I do Control-Shift-B, I will get a build succeeded. If I just sat here and pounded on my keyboard into this H file and hit Control-Shift-B, I get a build succeeded. That's because H files are not compiled. Only CPP files are. So you'll never see an error in an H file unless you include it in a CPP file. Okay. So we really don't need to implement the iTile and i.h because, you know, they're interfaces. They don't have implementation. There's nothing on either of these classes that can physically even be implemented. But we do need to go ahead and implement our level.h. So for the level.h, the first thing I'm going to go ahead and do is add his private members. All we're going to need on him is going to be a couple of vectors and a width and a height. So the first thing I'm going to do is add the width and the height. Then I'm going to bring in vector. And then I'm going to create a vector of iTile pointer called tiles. And then a vector of iEntity pointer called entities. Now I'm going to go ahead and create the corresponding CPP file for level, which is simply going to include level.h and implement all of his stuff. Also realize I have to add in the std on both of these private variables. You what?
And I just again had a minor brain fart there, because I was about when you brought in the vector, I was immediately thinking, but you've defined this position that you're using.
Oh yeah, I could see that.
And then yes, a vector being a list.
I don't know. I really don't get the terminology for vectors in C++.
Whoever was in charge of the naming flunked math. I think that's what it was.
All right, so I'm going to go ahead and do the level get width function, which simply returns our width, and then our level get height function, which simply returns our height. Then I'm going to go ahead and implement the void level set tile function. Now the set tile function is going to require us to create a helper function. So I'm going to go ahead and create the helper function in level. What I'm going to do is I'm going to add another private section in the level.h, and I'm going to write a method called int getIndex for xy.
This will look quite familiar.
Yeah, everybody who has been present for the entirety of today's class should be intimately familiar with the concept of this method. Okay, so what's the set tile function going to do? Well, all it's going to do is say tiles, first of all, what's the level constructor going to do? Can anybody, given that we have an std vector of tiles, what code should I put on line 5 that will reduce the amount of memory allocations my program needs to do? Can anybody remember all the way back?
Answers in BuzzNet, please.
What?
Answers in BuzzNet, please.
Yes, answers in BuzzNet. Can anybody remember all the way back into C++ 101? Was anybody paying attention to C++ 101? There's a very important, not required optimization I can make in the constructor of level that will reduce the amount of dynamic memory allocations this class will make.
And Rolling Stone, what does the keyword tell mean? And you haven't got a semicolon at the end of that.
Well,
oh wait,
it's not code. I'm going to start punctuating all my English sentences with semicolons.
Well, yeah, because the question was, what would you have to type here? That wouldn't work.
K7, I want to say new, but I'll be slapped. It's not new. Well, no, I was just saying it wasn't new, not that I was going to slap you. Okay, so it looks like a couple of people are on the right track, but what we really want to do, remember, this field is already instantiated. The fields in C++, if this is not a pointer, this gets instantiated when level gets instantiated. In fact, this gets instantiated when our level gets instantiated.
Hello?
So what I'm going to go ahead and do is say, in my object initializer, I'm going to say tiles, and then I'm going to pass in, or did I completely forgot the method name myself. No, I'm not going to do that in the initialization list. Instead, I'm going to do tiles.reserve width times height. Remember, a vector is a dynamically sizable list. I want to go ahead and reserve this amount of memory for working with this vector. And this will reduce the amount of additional computation that our level has to perform. So,
why just looking at what Rolling Stone came up with, which was well, as you can see there in the initialization list.
Yeah, there's not a constructor to vectors that take in that. Unlike, I believe C# in the list has a constructor that takes it. But notice how the only thing we have is an iter first, iter last, an empty, an iter first, an iter last, a const vector, another vector, blah, blah, blah. Oh. Ah, there it is. See, I freaked out because I knew it was there. I knew that constructor was there, but as I was flipping through, because I hate being wrong about things, I was just double checking my knowledge by flipping through, and then I didn't immediately see what I wanted to see as far as the correct implementation of this constructor. But if you look at this right here, this is what the overloaded constructor looks like for initializing a vector with an existing amount of items in it. And if that looks terrifying, it should. In fact, I can go ahead and write that out. It's std vector itile std. I believe it's just going to be a normal allocator, right? Yeah, std allocator itile pointer : size type. This is simply going to be a type def to probably to an unsigned integer. I want to point out that this is not something, this sort of syntax is not something we're really going to be going over in C++ 101. This is an example of what's called traits, kind of. Well, similar to traits, where we're using template specialization to change the types of things at compile time to other things. And it's this really weird esoteric concept that's quite prevalent in the STL.
Cool.
Okay.
So the long and the short of that is that does exist, and you can do it like that.
Yep. I was just thrown off because I was expecting to see something like an unsigned int count, but then I forgot that it specialized the traits to size t.
Cool. So
all right. So set tile. What's set tile going to do? Actually, can anybody go ahead and give me the implementation for set tile? Come on, wake up. I mean, I think it's a fairly... Okay, so the implementation to set tile is simply going to be _tiles at get index for x, y, position, get x, position, get y, equals ampersand tile. Can't really get more, I mean, well, it's...
You could break that out into a variable just temporarily to clarify.
Well, yeah, what we're doing is we're basically doing that. We're getting the index for an x and y position inside of our vector, and then we're assigning inside of our vector that particular indexed element to the memory address of tile.
Can anybody tell us why this will currently not work?
No. Oh, well, I'll back up really quickly and add something to your question. If I go ahead and hit Control-Shift-B, I do get a compilation. Oh, well, I do get a compilation. But can anybody guess why this won't actually move forward? Even though the compiler got done with it and said, this is cool, what's wrong with this code as it stands? And this is a very important aspect to C++. And we talked about this a lot in C++ 101. And it's very important to keep an eye out on situations that this might be an issue for. Anybody?
Bueller? As Rolling Stones in K73 appear to be the only people left with us.
Yeah, apparently. Okay, the problem is we'll get a linker error. And we'll get a linker error. It'll pass compilation, but we'll get a linker error because we didn't actually implement get index for xy, even though it's been prototyped.
K73. Oh.
What about the tile thing? No, that's valid. Remember that a reference only acts strangely during initialization. After a reference has been initialized, doing something like ampersand at will simply give us the address of that, just like a normal variable. Okay, so let's go ahead and implement the next method, set tiles. This is just a little convenience method. All it's going to do is say for auto x equals from dot get x smaller than or equal to 2 dot get y x plus plus. What did I do that for? I meant that. And then we're going to do another loop for auto y equals from dot get y. Y is smaller or equal to 2 dot get y plus plus. And then I'm simply going to say, well, I'm not going to bother making another method invocation just for one line of code in this particular case.
I'm not yet certain whether it will cause problems, but shouldn't you be doing the y on the outside? Or will that work itself through the methods and still work out in the wash?
If I did y on the outside, the result would be the exact same.
Okay, that's cool. There are situations, obviously, where you would be going the wrong way around otherwise.
Well, and yes, there. Case 7.3, I'm not intending to talk about cache lines today. I mean, the problem is everywhere you turn in C++, there's a discussion to be had that's probably more appropriate for a 105 class than a 102 class. Okay, so now I'm going to go ahead and implement the next function, which is simply going to be set entity. All set entity is going to do is it's going to start tracking the entity, which is going to become very important once we start talking about simulations. And then it's going to inform the entity where it is in the map. Next method we have is going to be move entity. I'm going to leave the implementation of move entity to last. Next we have render all. I'm going to leave the implementation to render all to second to last, or to last after move entity. And then finally we're going to go ahead and say level get index for xy, int x, int y, which is simply going to return width times y plus x. Okay, so I'm going to go ahead and reset everybody's ready and pause the video, resume. Alright, so let's go ahead and build out the render all method. The render all method is simply going to render all of the tiles and the entities. So for auto x is 0, x is smaller than width, x plus plus. For auto y equals 0, y is smaller than height, y plus plus. Then we're going to say auto tile equals tiles at get index for xy. Then I'm simply going to say cout tile dot, or tile get character. Actually, I do have a slight issue. I have two issues with this code as it stands. First of all, I need to go ahead and import the std namespace and bring in the IOStream header. And not only that, I'm going to have to go ahead and bring in our set character. I'm going to move set character to a private method of level for now. Now things may be, further down the line, things may be changed and refactored into a more graphics engine type thing. It's just I feel that abstraction is fairly unnecessary at this point, at least at this level of complexity of the program, which is really simple, actually.
Just to clarify, you've copied the signature across into level.h.
Yep.
In the privates at the bottom.
And then I'm going to go ahead and implement it right here. And then I'm going to go ahead and dump that in. And of course, I'm going to have to bring in windows.h. So to sum up the changes that I've made so far, other than the implementation of render all, because I'll be able to leave that on the screen in one go, all I've done is I have included in windows.h on level.cpp. I've included in IOStream, and I've imported the std namespace. On level.h, I've added a new private method called setCharacter with 3 parameters, a character and 2 integers. I'll leave that up just so people can look at that. And then I pasted the implementation that we had earlier. So now what I'm going to do is say, instead of cout that, I'm going to say setCharacter tile getCharacter x, y. Then I'm going to...
And he has, of course,
what?
Nuked it from where it existed before.
Yes. Well, yeah. I was never intending it to use again from there anyway, so...
No, I just for completeness, I did want to point that out.
So I just want to... Yeah, there's not going to be another thing there. Alrighty, so there's our method that will simply render the entire level in its entirety. The move entity method will be a little bit more complicated. The first thing we're going to do is validate that the position is within the bounds. So I'm going to say if pose getx is smaller than 0, or pose getx is greater or equal to width, or pose get y is smaller than 0, or pose get y is greater or equal to height, return. Otherwise, grab the tile that we're about to enter. So tile to enter equals tiles at get index for xy, pose get x, pose get y. Then I'm going to say if not tile to enter can enter entity, return. Otherwise, tile to enter entity. And then we're going to have to actually move the character. So I'm going to go ahead and say auto tile left equals tiles at get index for xy entity dot get position dot get x comma entity get position get y. And let me move this over a little bit. So that's the tile that we left. So what I'm going to do is I'm going to say set character tile left get character, and then of course the old position of the person. So I'm going to actually alias out the old position to a variable. Auto old entity position equals that. Then I'm going to...
Can I suggest a similar renaming takes place to tile left?
A what?
Do you mean the tile on the left? If not, I think you probably should change that to something else like old tile position. Or whatever it, yeah.
Okay, so then we'll go ahead and say set character entity dot get character. Then we want the new position, which is going to be pose get x, pose get y, and then finally we're going to say entity dot set position pose, and that should compile. Okay. So here's the move entity and render all methods. This will complete the level class as it stands. Now, the level class will be extended on further to support the concepts of simulation, but that's only going to happen once we start talking about timing, which isn't going to be until later. So for now, we have a basic way to render the entirety of our map and then move entities across our map and have tiles be capable of deciding whether or not an entity is allowed to enter, and then also giving tiles the opportunity to invoke their own logic if an entity enters a tile. So I'm going to go ahead and pause, and we're back. So let's go ahead and jump into main.cpp, and let's make a game.
Woot.
Now the first thing we go ahead and do is delete this, because we don't need it anymore. And of course delete that because it's no longer going to compile. I'm going to go ahead and import level.h. And then I'm going to go ahead and write two methods, or two classes. I'm going to write a basic tile that implements iTile. And of course, by implementing iTile, we must support this interface, which sadly I don't have ReSharper around to remind me what this interface is. So it's going to take in a char ch as a constructor parameter. It's also going to take in a bool can enter. And we're going to have two private fields, a character, and a bool can enter. Then I'm going to initialize them with the initialization list. So that should be fairly understandable. Now I'm going to go ahead and implement each one of these methods. The get character is simply going to return character. The can enter is simply going to always return can enter. Basically, I'm not putting any additional logic into this method, although this method is an interesting place to put logic in if you have specific game logic. The enter method, again, is another interesting place to put game logic in if you need it, but because this is a basic tile, I'm going to leave it blank. Then I'm going to create a basic entity, which is going to follow the same sort of scheme. Now, if I look at the entity header, we'll notice that we have to implement this interface. So I'm going to go ahead and paste in this interface, and
You can actually implement it.
do what?
I mean, are you actually going to do that on line 23?
Oh. I saw it. I knew that. I knew it. I knew it.
I know you knew it, because I just told you it. I was causing you to know it.
Okay, so this is simply going to be a basic thing. It's going to say return character. Get position is going to return position. Set position is simply going to set position to the position passed in, and collide is going to be empty. Again, collide is a great. Of course, we have to initialize our position. I'm going to initialize it to 0, 0 by default. So again, we have two basic implementations of a tile and an entity. They don't really do a whole lot of stuff, but that's fine because they're sort of the primary extensibility points of this game.
And it makes sense. They provide the very bare functionality that basically everything's gonna. That's the whole point of having a hierarchical structure to your code. And the first point is going to be fairly vague, really. But like Nelson's been sort of hinting at, it sets you up with the relevant places to do more complicated things when you need to further down the line.
Mm-hmm. I mean, already with the system, once we get simulation in, we can already start to implement things like enemies hitting players and causing them to die, or maybe even, once we get in simulations, we can put in things like AI-controlled entities, or entities that are like projectiles, or even entities that are items. And when they collide with another entity, they could give that player that item, for example. So it's a really nice sort of extensibility point.
And this ties into what William just asked, which was what's the point in passing the I entity into can enter? Or is what we have just temporary? It's kind of permanent, temporary, like part-time code. It's not permanent. Well, it is permanent, but it's.
It's if you need
you
it.
explain this.
The way I'm going to organize this is you'll be able to set one tile on a bunch of squares. So you can say, I want a empty tile that just represents a space, and I want that on the entire map, and then maybe I want a wall here and a wall here and a wall here. By passing in the entity into the can enter, we can reuse this tile across multiple positions in our level, and by passing in the entity into can enter, we can then just perform whatever computations we want based off the entity that was passed in. So it gives us a lot of fun stuff to play with.
It gives you the way I've always thought of these is it gives you the option if you need to.
Right.
If for some things you're going to need an entity, it's actually easier to just have that be there for the can enter than it is to. There's less code involved to just have it there for all of them than there is to specifically exclude when you don't need it.
Mm-hmm.
Wow, that was convoluted.
Well, no, yeah, I
hope
that
gets the point across.
Okay, so let's go ahead and build up a quick level. So I'm going to create a level, and I'm going to make it 20 by 20. I'm going to create a tile called empty. Now the empty tile, basic tile called empty. The basic tile is going to have a space for its character and a true for its can enter. And then I'm going to say level.setTiles. I'm going to pass in our empty tile, as well as position from 0 to 0 to 19 to 19. So that will fill our level with empty tiles. Then I'm going to go ahead and create another tile, so basic tile called wall, which is going to be represented with the hash, with a default of can enter to false. Then I'm going to wall in the level. So I'm going to say level set tiles wall position 0, 0 to position 0, 19. Then I'm going to say level set tiles wall position 0, 0 to position 19, 0. And I bet you guys can see where I'm going with this. So
I'd have thought you'd have made the obvious optimization.
So 19 in x to 0 goes to 19 in x and 19 in y. And then we'll set a wall from 0 to 0, hold on. Okay, so this is going to set the top wall, this is going to set the left wall, this is going to set the right wall, I think, and then this is going to set, so 0, 19 to 19, 19. So now if we do level.renderAll, we should get a rendering of a 20 by 20 level. And in fact, we do.
Very nice.
So now let's go ahead and put in an entity that we can control. So I'm going to say entity player, or basic entity player.
Spelling.
I'm going to give him a $sign as his thing, and then I'm going to say level.setEntity player and set him to 1, 1. Now I'm going to go ahead and say character input while input equals get character, which get character, I will talk about that in a second. That's in the conio.h file, which we'll talk about in a second. So I'll say while input equals get character does not equal a number. And the number I'm going to use is going to be 27. 27 is the escape key returned by conio getch. Then I'm going to go ahead and say if input equals w, then we're going to move the player up. So I'm going to say level move entity to the position of up. And what's up? Well, up is going to be the entity's old position. For x. Actually, I'm going to alias it out as well. So pos.getX, and then we're going to do a simple pos.getY minus 1, because that's up. Then we're also going to need WA or ASD. So what's A going to be? Well, A is going to be to the left. That means we want to subtract 1 from X. S is going to be down. That means we want to add 1 to Y. And D is going to be to the right. That means we want to add 1 to X. So what I'm going to go ahead and do is before the while loop gets entered, I'm going to say level.renderAll, because we only really need to render all at the beginning of the game. So now when I run it, what we'll get is a player that we can move around and be constrained by walls. And of course, they're walls simply because they return false.
Can you just stick a random wall somewhere in the middle of it so that we can see that it's
So if I go ahead and
not coincidence.
say level.setTiles wall position from, let's say, 4 to 4 to 6 to 6. So now there should be a nice little wall in the middle of our game. And notice how I cannot enter that wall.
Very nice.
And this is all handled not by some magical, ugly code that's buried in some if statement. It's handled by a simple matter of composition and polymorphism. So we were able to construct a level out of these two classes that we made. And now, when we start making our game more complex, there's going to be a lot of cool stuff we can do with these two classes and basically construct the entire game out of just these two classes.
And I'm sure there's quite a few, because I know we've got quite a lot of people who do all the programming courses with us, and hopefully you can already start to have things going around in your mind, how you can see that this is a very generic system in the best sense of the word. You can, all you need to replace the console stuff with your graphics API of choice, and you could be moving around in Unity, you could be moving around in XNA, you could be moving around in anything.
Okay, so this is all the code I really wanted to get done today. And so probably what I'm going to do, unless there's any awesome questions that I can address on video, I'm probably going to go ahead and pause the video and let everybody who's in the class today catch up. As far as homework, I just want people to get this code written out. Write it out. Writing code is so important. It's how you solidify knowledge. And once you get to the point where you have a nice little game that you can play around with and move your little character around and have walls being placed, it's a really good feeling to watch that, come together like that.
That would be a good time to point out that you should always make sure that you read the homework threads, whether you've been in the lesson or not. If you're doing homework, if you're taking the class and submitting homework, then you need to make sure that you read the thread when it gets put up, because for any specifics of... Oftentimes, by the time we get to this point, I'll be blunt, I'm quite tired and I forget to mention things. Just the cruft of it, like, oh, don't forget to zip it, or don't forget to do this, or submit these things. And those things I will always put in the homework thread. As it relates to this, seeing as I'm talking about it, I have actually remembered. What we will want from you will be... could you show your solution a second? I just think.
In Explorer?
The solution, yeah, that thing. That's it, Solution Explorer.
Oh, the Solution Explorer.
Yes, because all I actually want is Well, really, it's the header files and source files, isn't it?
What? Well, keep in mind though that these are just these folders actually bear no representation to the file system.
Oh, do they not?
Yeah, they're actually all in the
that's
same level,
dumb.
and you can see that by clicking on Show All Files. That's actually how it looks like in the.
Oh, right. Oh, well, in that case, yes. But so basically, what we need are your .h and .cpp files, and zip them up, or rar them up, or 7z them up, and put that archive into your whatever week this is folder.
Alrighty. Well, we do have some questions, but they're about some errors that people are having. Well, I guess we can answer these on video, honestly.
Well, one that I think, yeah, go on then. Might as well if you're going to answer them.
Should you use the else if for your move, or just if you do the latter you can move in diagonal, or does getch not work like that? No, getch does not work like that. Getch will always return just a single character. So meaning that the else if was just me saying, well, obviously input cannot. I mean, think about what you asked. This doesn't make any sense for multiple ones of these if statements to proc, because this one checks for input equal to W. This one checks to see if input is equal to A. These are mutually exclusive.
That's what you're saying is the way that this actually works. There is no input chord. It's not like with X and A, for instance, where you've got your key state.
Right. It's just a single variable that indicates what key was pressed for this loop. It says I can't instantiate basic tile because it's an abstract class. It will say that if you do not implement all of the members of your tile. Let me go ahead and show you what that would look like. If I delete the enter method and do a Control-Shift-B, you'll notice it says basic tile cannot instantiate abstract class. But if you look closer, you'll see it tells you exactly which method you didn't implement. In this case, it's the void iTileEnter. Now this can happen because you either forgot to implement a member, or you maybe misspelled the member you were intending to implement, or you have a different parameter list.
Well, the thing is, because of this sort of two-step process you go through and you build the H and then you sort of fill in the details, that's why you've had to put in these temporarily empty things like enter. And collide was another one that was empty for a while when you first did it. But you still had to actually put the that there in the CPP file in order for the H file for it all to do that, what you just said.
Yeah. It says I need to see the right side of the code in the while loop. Yeah, here's the while. Oh, well, actually, I'll remind me after this because there are some specific questions I wanted to get through. Where did getch come from? Getch comes from conio.h, which stands for console input output.h. Conio.h is a very ancient, it really is, a very ancient header file in Windows, and only works with Windows. It is not a cross-platform thing. In fact, you know it's not a cross-platform thing because of the underscore. You'll notice that there is, in fact, a getch method or function that doesn't have an underscore on it. But what they did was they realized, well, we want to be able to denote if something is a standard function or not, so they introduced the underscore to that. And that's why I'm putting it in there as well.
Can I, in that case, ask why are you using the non-interoperable one?
To my knowledge, there is no cross-platform way to do this.
But you just said there was a getch that doesn't have a...
Oh, yeah. It's the same function from the same header. It's just a long time ago, they made it without the underscore, but then they were like, well, it isn't a cross-platform thing, so we...
Oh, that's just a legacy thing. It's actually the same. Okay.
Okay, so if there are any more questions, I'm going to go ahead and stop the video. And I hope everybody learned some awesome stuff about coding, maybe hopefully solidified some of the stuff we talked about in C++ 101, at least seeing an example of true polymorphism, which I think is really cool, where we're able to compose a level through a lot of fun stuff.
Cool.
Yeah, here's 68. Okay, so I'm going to go ahead and stop the video. So goodbye, people.
This is what life used to be like.